In this lesson, we'll learn about another rule for derivatives called the chain rule. The chain rule is used when you have a function inside of another function. As a motivational example, let's take a look at the derivative of sine of x squared. We don't really have a rule for this, so we're just going to have to start off with the original rule. We've got the limit as delta x approaches 0. We're going to plug in x plus delta x and subtract off the inside function divided by delta x. Now you can stare at that and you could maybe try to figure out a way to do this, but this is not easy. This is really too difficult of a problem to figure out, at least in this form. This is too hard. However, we can try something new. This is what we call the chain rule. The chain rule is actually pretty difficult to prove. Here's the official setup of the chain rule and what it looks like. It looks complicated, but we'll learn a way to do this with insides and outsides. If you've got a function f, and inside of that function you've got another function g, then the derivative is the same as taking the derivative of the outside function, keeping the inside alone, and multiplying by the derivative of the inside function. Let's diagram what we have up here. The outside function is just the sine function. And we always write these down so that you're talking about composition. This is going to be the sine of x, and g of x is the inside function, x squared. So if you were to compose those, you would indeed get sine of x squared. With that said, f prime of x is equal to cosine of x, and g prime of x is equal to 2x. What we need to do is use this theorem. It says take f prime and insert g of x, which is x squared. The derivative of capital F prime of x is cosine of the inside times the derivative of the inside. That's probably not extremely clear, but we'll do plenty of examples. The derivative of the outside was sine became cosine. I left the inside alone. And then I multiplied by the derivative of the inside. Let's do some more. The first thing I want to do is write this as x cubed minus 3x to the 1/2. That way we can figure out what the outside function and the inside function is. Now I'm going to go ahead and do this differently than the way I started a moment ago. You can break these apart and you can look at each individual piece, but there's a much more intuitive process to the chain rule. The chain rule is not a very easy thing to learn. However, once you've gotten the hang of it, you will be able to do it just fine. Lots of practice on these. Here's what we do. You look carefully and ask yourself, what is the outside function? The outside function is the 1/2 power. The way that I usually word these is I think of it as 1/2 is my power, my outer function, and I'll just call it u to the 1/2. U stands for any quantities, particularly the inside. U to the 1/2 would have derivative 1/2 u, which is the inside, to the 1/2 minus 1, times the derivative of the inside. So this is the strategy. Take the derivative of the outside and leave the inside alone in the process. Then multiply by the derivative of the inside. We get 1/2 x cubed minus 3x to the negative 1/2 times the derivative of the inside is now 3x squared minus 3. At this point you should be getting pretty good at taking derivatives of polynomials. Next example. Here the outside function is sine. Particularly we'll call it sine of u. The derivative of sine of u is cosine of u times the derivative of the inside. Every time, take the derivative of the outside, leave the inside alone, call it u if you like, and multiply by the derivative of the inside. I get cosine of 2x times 2 for my answer. If you'd like, you could write that as 2 cosine 2x. Next example. Now this looks like a quotient, but remember, If a numerator or denominator is a constant, don't treat it like a quotient rule. That's a waste of your time. Instead, I'm going to write the function with a negative exponent. However, this does require the chain rule. When I take the derivative, the 3 stays in front. The outside function is the negative 1 power. I've got u to the negative 1, and I'll use the power rule. Negative 1 u, and then you subtract 1 from the power. Negative 1 minus 1 is negative 2. So negative 1 u to the negative 2. Just leave the inside alone and multiply by the derivative of the inside. So we get negative 3 times x squared minus 2, negative 2. And the derivative of the inside is 2x. You can leave it in this form. You might could simplify it a little bit, but right now I'm not concerned about that. Next example. This one is not clear as to which one is the outside function and which one is the inside function, unless you remember what it really means when you say sine squared x. That means this. It means the sine of x all squared. With that said, the outside function is definitely the square. If I've got u squared, the derivative is 2u times the derivative of the inside. 2 sine x, the derivative of sine x is cosine x. This example has a third power as your outside function. I'm going to think of it as u to the third. The derivative of u to the third is 3u squared. 3u squared times the derivative of the inside. 3 times 3x minus 2x squared squared, and the derivative of the inside is 3 minus 4x. Hopefully you're starting to get a feel for these. They take a little bit of time, so definitely practice some of these here in just a moment. Don't take the time after you've watched this video to go do something else. Definitely practice a few. This final example here, before I move on, is a little bit more complicated. Let me first rewrite this actually. Notice there's a cube root, but there's also a power. Top is the power, bottom's the root. And what I really get is x squared minus 1 to the 2/3. Top is the power, bottom is the root. This is actually even harder than the other ones we've done, but if we're careful, we can make this happen. Look and say, what is the outside function? The outside function is sine of u. Derivative of sine u is cosine of u. Leave it alone. Times the derivative of the inside. The inside function was this whole x squared minus 1 to the 2/3. If you look at this, this is still a function inside of another function. So I'm actually going to use the chain rule twice. Here's what we had a moment ago. Now, the outside function is the 2/3. If I've got u to the 2/3, I'm going to get 2/3 u to the 2/3 minus 1 times the derivative of the inside. Think of just this part of the function for what I just did. The outside was the 2/3. I took the rule for the 2/3. Then I multiplied by the derivative of the inside. Cosine of x squared minus 1 to the 2/3 times 2/3 x squared minus 1 to the negative 1/3. And finally, the derivative of x squared minus 1 is 2x. The next examples involve where the chain rule could show up in products and quotients. Let's look carefully at what's going on here. I do have a product of two functions. Let's use the product rule. Start off with that. 2 secant x squared is the derivative of the first times the second plus the derivative of the second times the first. Just start off with the product rule. For this one, the 2 stays in front. My function is secant u, if you will. But secant u has derivative secant u tangent u times the derivative of the inside times the square root of x minus 3. The outside function is the square root of u. So the derivative of the square root of u is 1 over 2 times the square root of u times the derivative of the inside. And then we've still got this 2 secant x squared floating around. Let's just clean all this up. We've got 2 secant x squared tangent x squared, and the derivative of x squared is 2x times the square root of x minus 3 plus 1 over 2 times the square root of x minus 3. Now the derivative of x minus 3 is just 1. We've got the 2 secant x squared also. This massive thing is the derivative of that function. Next example, e to the 3x plus 4. This is how you use the chain rule with e to the x. You think of it like e to the u. Well, the derivative of 3x plus 4, the derivative of e to the u is e to the u times the derivative of u. So we just get e to the 3x plus 4 times 3. You could write that as 3 e to the 3x plus 4 if you'd like. These next 2 problems are for you to try, and then we'll go over them. Feel free to pause your video, give these a try, and come back and see how you did. Okay, let's take a look. For this one, we've got a 5 in front, and we've got a u to the 4th. The derivative of u to the 4th is 4u cubed times the derivative of the inside. By the way, every time I say the derivative of the inside, if you feel fine with it, just say the derivative of u. That works also. Cleaning this up a bit, I get 20 times 2 minus x cubed cubed. And the derivative of the inside, the 2 goes away, and I get negative 3x squared. That's it. We'll leave it at that. The next one, hopefully you guys did, e to the negative 2 over x. Same thing. We think of it like e to the u. So the derivative of e to the u is e to the u times the derivative of u. So let me copy. Now if you recall the strategy for this, we think of it as negative 2 x to the negative 1. So when I take the derivative, I get, bringing the power in front, positive 2 x, and subtract 1 from the power to get negative 2. I'll just leave it like that. Here's some additional problems for you to try. While we will not go over these problems in the video, these can give you some excellent additional practice that you really might need right now after watching this video. Remember, this is a bit of a difficult concept, so make sure that you take a look at it right away and see what you can do with it.